Hi, so for today we're going to talk about Laplace Transform. This is an introductory video all about Laplace Transform, and we will be solving Laplace Transform of a constant and a simple function in terms of time. Okay, so this is an introduction in advanced engineering mathematics. So let's start. So what is Laplace Transform? Usually Laplace Transform is used to convert an f of t function in terms of time, okay, in terms of t, into the S domain. Okay, so from time domain to S domain, that's what the Laplace transform do. So we have f of s here. Okay, in order for us to get the Laplace transform of any f of t here, here's the formula. The Laplace transform in f of s is equal to the integral of f of t multiplied by e raised to negative st dt evaluated from 0 to infinity. Okay? So, from time domain to S domain is the Laplace transform. So, we shall be memorizing this formula in order for us to convert some function in terms of time into S domain. So, let's get started. For number one, what is the Laplace transform of the constant 1? So, here, our f of t, even though it has no term t included here, this is still considered as an f of t, okay, in time domain. So, what is the Laplace transform? So, simply, we have f of s is now equal from 0 to infinity of f of t, which is 1, e raised to negative st dt. So, simply, we evaluate the integral from 0 to infinity of e raised to negative st dt. Okay? And remember that we are integrating in terms of t. So any other variable inside the integrand is considered, any other variable other than t is considered as a constant inside the integrand. So we have from 0 to infinity, okay, of negative st dt, okay, if we let u is equal to negative st, our du is equivalent, with respect, we get the derivative of this with respect to t is negative s dt. And if we get dt here, so we have dt is equivalent to du over negative s. So if we perform u substitution here, so we have integral from 0 to infinity e raised to negative st, which is u. Okay, and our dt is du over negative s. Okay, so I can factor out 1 over negative s because s is considered as constant here as we are integrating in terms of t. So we have negative 1 over s, integral of from 0 to infinity of e raised to u. And we know that the integral of e raised to negative e raised to u is simply e raised to u. Okay? So evaluated from 0 to infinity. So, what will happen? We need to back substitute the value of u, wherein u is equal to negative st. So this would become e raised to negative st evaluated from 0 to infinity. Okay? So, we need to evaluate the definite integral or the limits. So we have negative 1 over st, or no, negative 1 over s, e raised to negative s multiplied by the upper limit, which is the infinity, minus e raised to negative s multiplied by 0, the lower limit. So e raised to negative s times infinity, this is considered as 0. This is equal to 0. 1 over s, 0. So this is e raised to negative s times 0 is e raised to 0, that is equivalent to 1. So if we multiply this is 1 over s. So the Laplace transform, okay, therefore, the Laplace transform of 1, okay, is the f of s of 1 is simply equal to 1 over s. Okay? So that's the answer to our problem number 1. The Laplace transform of a constant 1 is equivalent to 1 over s. So let's try another one. The Laplace transform of a certain constant, let's say again 5. Okay? So from the formula f of s is now equal to the integral from 0 to infinity of f of t e raised to negative st dt. So we have from 0 to infinity, integral of from 0 to infinity of f of t, which is 5 e raised to negative st dt. We can factor out 5 outside of the integral sign. So 5 integral of from 0 to infinity e raised to negative st dt. And we can again integrate this. If we integrate this again, we have to let u is equal to negative st. Our du with respect to t is negative s dt. So our dt would now be du over negative s. So if we substitute that, we have e raised to negative or e raised to u multiplied by du over negative s. Okay? So that is what dt is equal to. So I can factor out negative 1 over s because we are integrating again in terms of u. So we have negative 5 over s here from 0 to infinity of e raised to u du. Okay, if we evaluate that again, so negative 5 over s, the integral of e raised to u is simply e raised to u evaluated from 0 to infinity. Don't forget to back substitute what is the value of u. So we have negative 5 over s, okay, e raised to negative st. That's the original function or the original value of u. So what will happen here? Evaluating the limits. So we have e raised to negative s multiplied by infinity minus e raised to negative s multiplied by 0. E raised to negative s multiplied by infinity is simply equal to 0. E raised to negative s times 0, this is e raised to 0, which happens to be equal to 1. So what will happen? We have negative 5 over s multiplied by 0 minus 1. This is e raised to 0, which is 1. We have a negative here, so we have negative 1. So that is equivalent to 5 over s. So simply, the Laplace transform of the constant 5 is 5 over s. Okay? So the pattern here, okay, we have a table. If I'm going to get the Laplace transform of 10, okay, simply that is 10 over s. Okay? 10 over s. Because whatever the Laplace transform of a value of any constant is simply the value of constant over s. Okay? So I have shown you the hard way, okay, the long method, before we proceed to table method. Okay? So the table of Laplace transforms. So, for example, let's say example number 4. Okay? So simply, again, if we get the Laplace transform of any constant, okay, what will happen is the constant on the numerator divided by simply ds. Okay? So how about if we get, for example, the simplest f of t, which is t. Okay? The Laplace transform of t. Again, we're going back to our formula. F of s is now equal to the integral from 0 to infinity of f of t e raised to negative st dt. Our f of t here is simply t. So we have 0 to infinity t multiplied by e raised to negative st dt. So, in order for us to get this, to get the integral of this, we need to recall our integration by parts. This should be integration by parts. We have to let u, priority in choosing u is Liate, logarithmic, inverse, algebraic, trigonometric, and exponential. Priority in choosing u. So, this is what? A polynomial, let's say, with a degree of 1. That is, let u is equal to t. So, the derivative of u with respect to t is simply dt. Okay? And the remaining is our dv, e raised to negative st dt. If we integrate this to get v, okay, this is with respect to t. So, any other variable is considered as constant. So, what will happen? U substitution again, we shall get negative 1 over s e raised to negative st. If you are confused, I choose u as negative st again. And du with respect to t is negative s dt, and in terms of t, dt, I get the dt, so that is du over negative s. So that's why we have a negative 1 over s here. Okay? I hope that's clear. And we're going to use the formula for integration by parts as ub minus the integral of v du. Okay? ub minus the integral of v du. So what will happen? We have the integral. Okay, let me just rewrite this here. So we have the integral u, which is t, multiplied by v, which is negative 1 over s e raised to negative st. Okay, evaluated from 0 to infinity. Okay, because that's a definite integral. So we need to evaluate also, we need to distribute or the limits. So minus the integral from 0 to infinity of v du. Our v is negative 1 over s e raised to negative st. That is our v. Our du is simply equal to dt. Okay? So let's first evaluate the integral or evaluate the limits here on the left side of our equation or in this side of our term. So we have negative t over s e raised to negative st evaluated from 0 to infinity minus the integral of 0 to infinity of negative 1 over s e raised to negative st dt. Okay? So if I'm going to substitute infinity and 0 as the higher and lower limits in this term, so we have negative infinity over s, e raised to negative s multiplied by infinity. We know that e raised to negative s multiplied by infinity, that is equivalent to 0. Okay? Because this is 0, 0 multiplied by this is simply 0. Minus, because that's definite integral, negative 0 over s, okay? E raised to negative 0 times 0, okay? So 0 over s simply is 0 if we multiply this by any term here. So 0 times any number would be 0. Okay, that would be 0. Okay, this is the minus brought by the integration and by evaluating the definite integral. Okay, and this is minus because of this. Again, and we have again minus because of this. Okay, the integral from 0 to infinity of negative 1 over s e raised to negative st dt. So simply, this term is equivalent only to 0. Okay? So our equation simplifies now to negative the integral of 0 to infinity, this one, of the negative 1 over s e raised to negative st dt. Okay, so I can factor out negative 1 over s, okay, because we are integrating with respect to t, and that is a constant. So negative times negative 1 over s is simply 1 over s. Integral from 0 to infinity of e raised to negative st dt. Okay? So again, in order for us to integrate this, we have to let, again, u is equal to negative st. Our du is negative s dt. Our dt, therefore, is du over negative s. So what will happen here is that we have 1 over s. Okay? Integral from 0 to infinity of e raised to u multiplied by du over negative s. I can factor out negative 1 over s outside of the integral sign. So that would be 1 over s multiplied by negative 1 over s from 0 to infinity of e raised to u du, okay, integral of that. So we have negative 1 over s squared, numerator times numerator, denominator times denominator. So yeah, I have e raised to u evaluated from 0 to infinity. But again, u is equals to negative st. So back substituting that, so we have negative 1 over s squared multiplied by e raised to negative st from 0 to infinity. So evaluating the limits, so we have negative 1 over s squared multiplied by e raised to negative s multiplied by infinity. E raised to negative s multiplied by infinity is equal to 0 minus e raised to negative s multiplied by 0. E raised to 0 is simply 1. So we have what? We have negative 1 over s squared multiplied by 0 minus 1. So, or simply negative 1 over s squared multiplied by negative 1, that is 1 over s squared. So, the Laplace transform of f of t equals to t is simply equal to 1 over s squared. Okay, so let's try to solve again another problem. Number 5. Let's take the Laplace transform of t squared. A while ago, we have solved the Laplace transform of t. Now, we get the Laplace transform of t squared. Again, the formula for Laplace transform f of s is from 0 to infinity, the integral from 0 to infinity of f of t multiplied by e raised to negative st dt. So simply substitute, we have from 0 to infinity of the integral of t squared multiplied by e raised to negative st dt. And again, this is integration again by parts. Okay? This is integration by parts wherein we have to let u is equals to t squared and our du with respect to t is 2t dt. And again, our dv is e raised to negative st dt. And if we integrate this again, we have seen this a while ago, that is negative 1 over s e raised to negative st. Okay? So performing again the formula uv minus v du. So we have u times v, that is negative t squared over s e raised to negative st evaluated from 0 to infinity. Okay? Evaluated from 0 to infinity minus the integral from 0 to infinity of v du. v du, so we have negative 1 over s e raised to negative st. Our du is 2t dt. So, what will happen here is first, okay, we need to evaluate this. So, evaluating the limit, so we have negative infinity squared over s e raised to negative s times infinity, okay, minus, that's minus, again, minus because of the definite integral, and we have a negative again because of this function. The original function is negative. So negative 0 squared over s e raised to negative s times 0, okay, minus, okay, this is that minus sign, that is that minus sign. I can factor out 2 and negative 1 over s. So if I'm going to multiply 2 multiplied by negative 1 over s, that is negative 2 over s. And multiply here by the minus sign, this would become 2 over s integral from 0 to infinity of e raised to negative st multiplied by t dt. Why did I choose, okay? Why did I choose to uh, factor out negative 1 over s outside the integral? It's because we are again integrating with respect to t, and any variable other than t inside the integral is considered as constant. So, okay, what will happen here? E raised to negative s multiplied by infinity is 0. So 0 times this term is simply 0. And again, this is 0 in the denominator or in the numerator. So 0 multiplied by any number is still 0. So the whole term, this whole term again is 0. So we have, again, the remaining is 2 over s integral from 0 to infinity e raised to negative st multiplied by t dt. Again, okay, in order for us to clearly see 2 over s from 0 to infinity, that is t multiplied by e raised to negative st dt. Again, this is an integration by parts again. So we have to let u equal to t. Our du is equals to simply dt. Our dv again is e raised to negative st dt. And our, if we integrate this, that is equivalent again to this. So we have negative 1 over s e raised to negative st. Okay? So we can perform again the integration by parts. Note that this is outside of the integral. So whatever the integral of this is multiplied. Okay? So we have uv again minus v du. Okay, that's the integral. That's the integral for this integration by parts, the formula. So we have 2 over s multiplied by uv. Okay, our uv is t times negative 1 over s e raised to negative t st. So we have negative t over s e raised to negative st evaluated from 0 to infinity minus the integral, okay, that's the minus here, integral from 0 to infinity of v du, negative 1 over s e raised to negative st. Our du is simply equal to dt. So, 2 over s multiplied by, if we evaluate this, negative infinity over s e raised to negative s multiplied by infinity, we know that this is 0, okay, minus negative 0 over s e raised to negative s times 0. We know that this is also equivalent to 0. That's right, because 0 times any number is 0. So this whole term, again is equal to 0. That is minus, okay? I can factor out negative 1 over s. If I'm going to factor out negative 1 over s, we have a negative 1 over s here, that is minus sign, so this would become plus 1 over s integral from 0 to infinity of e raised to negative st dt. Okay? So again, to simplify, we have 2 over s, this is 0, 0, so multiplied by 1 over s integral of from 0 to infinity of e raised to negative st dt. Okay? So I can distribute this inside. So we have 2 over s squared of the integral from 0 to infinity of e raised to negative st dt. And again, if we integrate this, we have to let u is equal to negative st, du is negative s dt, and the dt now is equal to du over negative s. So we have 2 over s squared, integral from 0 to infinity of e raised to u multiplied by du, which is, or dt, which is du over negative s. I can again factor out negative 1 over s outside of the integral sign. So negative 1 over s integral from 0 to infinity of e raised to u du, because I'm integrating with respect to u. So we have negative 2 over s cubed integral from 0 to infinity of e raised to u du. And this is negative 2 over s cubed, okay, simply e raised to u from 0 to infinity, but our u is equivalent again to negative st. Okay, so from 0 to infinity. So, evaluating the limits, so we have negative 2 over s cubed multiplied by e raised to negative s multiplied by infinity minus e raised to negative s times 0. So again, this is a 0. Again, this is 1. So we have negative 2 over s cubed multiplied by 0 minus 1, or simply negative 2 over s cubed multiplied by negative 1 is simply 2 over s cubed. So that is the Laplace transform of our, okay, function t squared. Okay? So as you can see here, we have a formula in actually finding the Laplace transform, okay, Laplace transform of any t raised to n. And that is equivalent to the n factorial over s raised to n plus 1. Okay? So if you, as you can see here, okay, as you can see here, our f of t here is t. So if we are going to apply this, the Laplace of t in our formula, so the Laplace of t, okay, the Laplace of t, so this is raised to 1, okay, t raised to n, this is t raised to 1. So n factorial, 1 factorial is 1, okay, and we have s, this is exponent is 1, so n plus 1, so 1 plus 1, that is simply 1 over s squared, just as like we have here. Okay? And if we're going to apply this to our t squared, okay, Laplace transform, okay, let's say here, Laplace transform of t squared, again, our n here is 2, that would be 2 factorial, s raised to 2 plus 1. So 2 factorial is 2 over s raised to 2 plus 1 is s cubed. So this is the answer. Okay? Again, if we're going to get the Laplace of t cubed, Okay? If we perform long method by integration by parts or simply by table, we have 3 factorial over s raised to 3 plus 1. 3 factorial is 1 times 2 is 2. 2 times 3 is 6. So that would be 6 over s raised to 4. So that's the formula. I've shown you the long method in order for you to fully understand how to transform Laplace transform even without the use of tables or the formulas. So I hope you guys enjoyed this very first video in Advanced Engineering Mathematics, and I hope to see you guys for my next videos. And please, if you are new to my channel, please don't forget to subscribe. Thank you so much for listening, and God bless.